We are starting the last chapter of the year, and actually, in this chapter, we're only going to do a couple sections or kind of pull out the sections that I think are the most important in moving on to future math classes. Kind of what are the skills that you need the most. So, the section that we're doing today and actually tomorrow, we're going to kind of break it up into two parts, is section 8.4, and the focus is on rational expressions and how we simplify them. So a rational expression is just anything that can be written as a fraction or as a quotient of two polynomials. So you always see that division bar. Our job is to come up with what's called simplified form, meaning that anything in the numerator and denominator that they have in common as far as factors, those common factors are canceled or reduced. So we're going to do a lot of talking about like exponent rules and reducing fractions, but we're also going to do a lot of things with factoring because factoring is necessary in order to see what can actually reduce or cancel. So I just kind of have some things of like, what are you allowed to do with fractions? Well, one thing you're allowed to do with fractions in the very first piece here is you're allowed to just multiply straight across. When you're multiplying fractions, you can multiply the numerators together and the denominators together. And if they have nothing in common, then there's nothing more to do. If you multiply them together and they have a common factor, so the second one shows that they both have a common factor of k, and that could be a number that they both have in common, or it could be a variable they both have in common, they cancel. In addition, if you have a number or a variable that they have in common that is a factor outside of a parentheses, they cancel. And then finally, when you have things that are being added or subtracted, in order to cancel here, the entire factor must be the same in order to cancel. So I can cancel, for example, an x plus 2 in the numerator as long as there's also an x plus 2 in the denominator. So you need that common factor in order to cancel. Usually the mistake students make is they start canceling all sorts of things, even if they're not factors, even if they're things that are being added or subtracted. For example, what I mean by that is if you have x plus 2 on top, and x plus 7 on the bottom, you're not allowed to cancel the x's because they are not factors. They're currently being added. We would call them add-ins if we were back in elementary school. You cannot cancel that and say, oh, it's just 2/7. You can only cancel something that is being multiplied that is identical. So if I put this in parentheses and put a 8 out here, and I put this in parentheses and I put an 8 out here, now that's a factor, I can cancel it. But I can't cancel things that are being added or subtracted. So kind of a little checklist here, just basic things that we're going to be doing. We are going to be doing a lot of factoring. I'm going to start with the ones that don't have factoring, and then I'll kind of build my way up. We're going to cancel any common factors. Again, factors are things that are being multiplied. We're going to reduce coefficients if we can, and we're also going to use some exponent rules if possible. So I'm going to take you, this video is going to focus on ones that don't have factoring and then ones that do, and we're going to get into more multiplying and dividing ones in another video. I took these straight from Delta Math because I figured the best way to explain how to do the assignment is to do some that are very similar to it. So we're going to start with the ones that are just a single fraction. You're going to have numeric pieces that may or may not reduce, and you're going to have variable pieces that may or may not reduce. When you're doing these and that don't have any addition or subtraction, you're truly looking at the numeric piece first and then the variable piece second. So for this first one, 9/7 does not reduce. So that's the first thing I'm going to check. Now my x's, I can reduce because I can use exponent rules. I have 4 x's on top. I have 2 on the bottom. My exponent rule says to subtract, so I end up with 2 on the top and none on the bottom, because when I cancel these two, it'll cancel with 2 of these. And then the numeric piece, the coefficients, since they did not reduce, stay. So that's how you would type in your answer. Essentially, you're just canceling like factors. These are really fast. The next one also has a coefficients that don't reduce. 12/5 does not reduce, but the x's do. We have 1 x on top, we have 4 on the bottom. When I subtract here, I want to leave the x's wherever I had more to begin with. So since I had more in the denominator, my leftovers are going to be in the denominator. I have 3 more in the bottom. So when I cancel this one, it's going to cancel one of these and drop it down to the third power. My coefficient did not reduce, so I'm going to leave it as a 12 on top and a 5 on the bottom. Last one is an example of the opposite. This time the coefficient reduces, but the variable doesn't. So in this case, 99/77 will reduce to 9/7. You can divide each by 11. And since there's only x's in the bottom, there's nothing to reduce or cancel with, you're still going to have an x to the third in the bottom. So I wanted to kind of show you ones that have variables that reduce and end up in the numerator, variables that reduce and end up in the denominator, and ones that don't have variables reduce, but you do have to look at the coefficients. So those are going to be the first ones you're going to do on Delta Math, and they should be really fast. So your next ones are ones that we can't start reducing right away because they are not currently written as factors. They're currently written as things being added or subtracted. So a common mistake with this one is I've seen students go, oh, well, there's an x squared on top and x squared on the bottom. I'm just going to cancel it. I can't cancel it because it's, not, again, not being multiplied by anything. It's being added. So in order to start canceling, I have to factor first. So you're going to do a lot of basic factoring. The math nerd in me absolutely loves this section. It's funny, it's at the end of the year, but it's one of my absolute favorites because it involves so much factoring. So I need numbers that multiply to get 40 and add to get 13. So that is going to be 5 and 8. Everything's positive here. So that's how you factor the numerator. In the bottom, I need numbers that multiply to get negative 8 and add to get positive 7. So that's going to be an 8 and a negative 1. Once you have it factored, now you can look and see if anything will cancel. And you do have an x plus 8 on the top and an x plus 8 on the bottom. Those are like factors that cancel. Anything that does not cancel is your final answer. So your final answer will truly be just typing in whatever was left after you go through this process. Same thing on the next one. I need numbers that multiply to get negative 28 and add to get 3. So multiply to get negative 28, add to get 3. If you don't want me to give away the answer while you're thinking of it, you can always pause the video. It is x plus 7, x minus 4. On the bottom, I need numbers that multiply to get negative 40 and add to get positive 6. Again, if you don't want me to give it away, you can pause. It would be positive 10 and negative 4. And again, you're looking to see if you have any like factors. You do. The x minus 4 and the x minus 4 cancel. This is your final answer. When you type in a delta math, if you want to put it in parentheses, you can, but you don't have to since there's no other factors. Show you a few more of those that have a little different factoring just to kind of give you some variety here. The goal is still the same. Factor as much as you can, reduce or cancel as much as you can. The numerator of this first one, you can actually take out a GCF. Both of them have an x squared, so I'm going to pull an x squared to the front, and that's going to leave me with x minus 6, and I can't do anything more with that. That's a GCF only. The denominator is a basic FOIL factor. I need numbers that multiply to get negative 48 and add to get 2. That's going to be a positive 8 and a negative 6. Again, looking at what is alike on the top and bottom that will cancel. So an x minus 6 is on top and bottom. So your final answer is you're left with an x squared on top and an x plus 8 on the bottom. Next one, I can pull out a 12 because they both 12 and 84 are divisible by 12. I can also pull out an x squared. So this is another GCF one. And when I do that, I'm left with x plus 7. Can't do anything with the bottom. However, now that I've factored the top, now I'm allowed to start canceling. This x squared and this x squared will cancel. They are both factors that are the same. The 12 and the 4 will reduce to 3 over 1, or just 3. You are left with just 3 and an x plus 7. If you want to distribute, you can, but it's also perfectly fine to leave your answer as 3 times the quantity x plus 7. You don't have to put a 1 in the bottom. Next one, the numerator is a GCF. You can take out a 2x, which leaves you with x minus 6. The bottom is a difference of squares, so I'm glad that I'm trying to show a variety in these examples. This is an x plus 6, x minus 6. Anytime it is x squared minus a perfect square, you're going to get difference of squares factoring. This x minus 6 and this x minus 6 cancel, so you get a 2x on top and an x plus 6 on the bottom. And again, I can't cancel anymore. It's so tempting to want to cancel the x on top and the x on the bottom. That x on the bottom is not being multiplied, it's being added. Don't over cancel. That's probably the number one mistake. Last one here, the top is a trinomial or a FOIL factor. So I need numbers that multiply to get negative 28 and multiply to get positive 28 and add to get negative 11. That's going to be a minus 4 and a minus 7. The bottom is GCF. You can take out a 2x squared and you're left with x minus 8. And I wanted to show you this one purposely at the very end of this video to show you that not all of them will reduce. I looked in Delta Math and they actually have ones that will say there is nothing they have in common. When that happens, this is your final answer. So it doesn't happen a lot, but if you do all the factoring and you still don't have anything in common, your answer is just all the factors where they are and you just type it in as is. You will need parentheses when you type that in. And that is the end of this first video, how we simplify rational expressions.